Hello viewers, this is Quadratic now taking you through this tutorial on how to obtain complex roots of quadratic and cubic equations with real coefficients. So we shall start with quadratic equations. Now if this quadratic equation az squared plus bz plus c equal to 0 has complex roots, those roots can be got using the quadratic formula z equal to negative b plus or minus square root of b squared minus 4ac. That will be the numerator, and the denominator will be 2a. So we shall use this formula to solve problem 1. And we want us to solve z squared plus 2z plus 4 equal to 0. So in this case, we shall compare this equation with the given general equation of a quadratic equation, whereby now a will be 1, b will be 2, and c will be 4. So when you substitute in this formula, you shall come up with b as 2, b as 2, which is 2 squared, a as 1, which is 4 times 1, times c, which is 4, over 2 times a, where a is 1. So when you simplify this under root, we shall get negative 12. Now negative 12 is the same as 4 times 3. So that 4, square root of 4 can come out to become 2 root negative 3. And that root negative 3, now these 2 and these 2 are common, so you can factorize them out, and they can be divided by 2 to get 1. So in the end, we shall get negative 1 plus or minus root 3 times negative root 1. And we know that negative root 1 is equal to I, so we shall come up with negative 1 plus or minus I root 3. So those will be the roots for the given quadratic equation. So one root will be negative 1 plus I root 3, and the other one will be negative 1 minus I root 3. So in this case, you should realize that this is the conjugate of this, and therefore should note that if a complex number is a root of a given equation, then its conjugate is automatically a root. So this will be used in then coming lesson 3. So we shall now go to problem 2. Solve for z in z cubed minus 7z squared plus 19z minus 3 equal to 0. So now this is the cubic equation, and they want us to solve it. So in this case, you have to first look for factors of this constant 13. Factors can be 1 and 3. So in other words, one of the roots should either be plus or minus 1 or plus or minus 13. So when we begin with positive 1, substituting positive 1 in this equation, we shall come up with 0, meaning this is a root because it leaves no remainder. So we have already got one root, which is z equal to 1. So the other roots will be got by dividing the factor, which is z minus 1, divide this formula or this equation by the root or the factor. So you can either use synthetic method or long division. So if we begin with synthetic method, we have to put there our one root, which is z equal to 1. Then here we put the coefficients of the given equation, which is that. So the coefficient is 1, negative 7, 19, negative 13. 1, negative 7, 19, negative 13. After doing that, we shall now say, bring this one down. So 1 here, 1 here. What is here is what we bring here down. After that, you will say 1 times this. So 1 times 1 will give you 1. So that 1 you get is what you put under negative 7. After that, you again add this plus this, you get negative 6. Now this negative 6 again multiplied by this root, which is 1, to get negative 6. And that negative 6 is what you put here. And you do the same, add to get 13. This 13 multiplied by the root, which is 1, to get 13. When you add, you get 0. Now this 0 means that the remainder is 0. What is here is called the remainder. So the remainder is 0. Since the remainder is 0, we shall now say this equation is the same as the one factor, which was from this, multiplied by this. Now this equation is got from here. This is the quotient of z squared, quotient of negative quotient of z, which is negative 6, which is that, then the constant is 13. This one denotes the remainder, which is 0. So that's how they can factorize a cubic equation to get one linear equation and a quadratic equation. You can also use long division, whereby you first write your equation here, then you write your factor here. So in this case, we shall say this highest power, which is z cubed, divided by this highest power, which is z, to get z squared. Write z squared there. After that, you multiply this z squared through the divisor to give you z cubed minus z squared. So after that, you shall now subtract this, and this gives you 0. This and this gives negative 6. Then this minus 0, you get the same value, 19z. This minus 0, you get the same value, negative 13. After that, you still repeat the same procedure. Get this highest degree divided by the highest degree here to get negative 6z. So negative 6z multiplied by throughout, you get negative 6z squared plus 6z. Still do the same, subtract. Here it will be 0. Here it will be 13z. Here it will be negative 13. So still highest power is, which is negative 13z, divided by the highest power here, which is z, you get 13. 13 multiplied out by this, you get this. So when you subtract, you get 0. So since what is here denotes the remainder, but since it is 0, it means that this was the factor. So in that case, we shall now express the cubic equation in two parts: linear, which is this divisor, and this, which is the quadratic. But they wanted us to get other roots. So if this is equal to 0, it implies that this can be replaced by this. When you replace it by that, we shall come up with this equal to 0. So either this is equal to 0 or this quadratic is equal to 0. We already know this. Now we are interested in getting the values of z for this quadratic equation. So in that case, we shall use the quadratic formula. Substitute our b is negative 6, which is here negative 6 and negative will give you positive. Come here, b squared is 36 minus 4, a is 1, which is 1, times c, which is 13, bring it there, divided by 2a. Now 2 is that, a is 1, so you put your 1 there. When you simplify, you come up with that. So 16, negative 16 is the same as 16 times negative 1. So 16 gives you 4, and negative 1 remains under root. But negative 1 is the same as I, so you put your I here. Now here there is a common factor. 2 is common in the numerator, so when you divide through, open bracket. When you simplify, you come up with 3 plus or minus 2i. So in that case, you have got the other roots. One of the other root was z equal to 1, another one is z equal to 3 minus 2i, and another one is z plus 2i. So those are the roots. So that's how they solve cubic and quadratic equations. Thank you for watching. I remain Wagada Ronald, and please subscribe to my channel, Rowa e-learning platform. Thank you.